So I won't spend a lot of time on the stats. We all know the problem. Admirable targets of 250,000 homes a year from the federal government in an industry that over the last decade has produced an average of 158,000 homes a year. Good luck. We know that that's not going to be met. The problem, as Alice mentioned, the slower the supply, the greater the demand, the higher the price, input costs going up at the same time. So we were looking at this 2 years ago, thinking about a desire to change the trajectory of social and affordable housing as private investors and private capital, realised that modern methods of construction was available in other parts of the world, and that the burning platform in Australia was starting to catch fire for this solution. So, as I said, focus on changing the trajectory. We've had some early engagement with government bodies and some community housing providers just to test our investment thesis and our production thesis, including the trip to the UK I mentioned earlier today. Treasurer Mulligan, Under Treasurer Tammy, and myself in that photo. Matt was on that trip. Those are modularly constructed homes. That's a 3D printed brick mesh bonded to fibre cement to get that aesthetic. So please don't mistake that for being a full brick wall. All right. So right now, we haven't even pulled back the curtain yet to the market, which Joe asked me about earlier today. And just those early engagements, we've got a pipeline north of almost 2,000 dwellings in pent-up demand just here in South Australia. Recognise the problem. So we said, all right, well, you can't build dwellings in the same old way. It's the Einstein problem. If you bash your head against the wall and expect a different result, you're insane. We needed innovation to boost productivity. We thought, okay, we could use technology and advanced manufacturing. Started to do a lot of work around that. I'm going to go really quickly. You can stop me anytime you like. Part of the problem, which we talked about a little bit earlier, and I think Matt alluded to it in some of the questions. So we know that to even get close to the 250,000 homes per year now, we have to have 83,000 more tradespeople now. I'm not sure if anyone's got that sort of power to just go, we'll have another 83,000 tradespeople. Thanks, of course. We import them if we need to, but then where do they live? Big problem. So our solution allows us to reduce construction time by about 50%. There's solutions in terms of the robotic automation that drive that. There's also some innovative construction solutions that take trades and how they do things off the critical path, which is a fancy engineering term for the part of the build that makes the most risk for the build's time. We do most of that in the factory in a slightly different way, and then you connect things on site really quickly. As an example, we were talking with a CHP recently and showed them that on a 2-level terrace home, you could do that entirely without scaffolding and still work safely using our methodology. That's about $11,000 a home in savings, which has nothing to do with our product, everything to do with our method. All right, so let me take a moment. Fingers crossed the video works. It's got sound. I'm not fussed if the sound works or not, but let me introduce you to the future of house production. What you'll see is the line that we've invested in. It is in its commissioning and testing phase in this video at our robotic supplier in Germany. It is now completely repackaged up and ready for shipping. And I invite you to have a look at how that might work. Oh, sound. While the robots are doing their thing, that line is 104 meters long, it's 14 meters wide. There are 12 of those 6-axis robots on it. Each one of them, I know we're in Adelaide, so most of us have been to the zoo here. We all understand how big an adult giraffe is. They're about that big. I appreciate my accent gives away where I'm from, so adult giraffes is something I know about. Incredible to think about 2 years of production of the robots, 2 years of software engineering distilled into a 5-minute video to show you one panel going down the line. During the latter part of the presentation, I'll show you some of the ESG credentials that come from our timber ethos. So we only use timber in our framing and our structures. It actually caused our engineering some problems because timber being a natural product isn't always true. So we've had to build in straightening opportunities down the line that are all automatic as well. So it picks up product that's not accurate and pulls them this way. So the line itself can make, it has part limits, so it can make a panel or a floor or a wall up to 12 meters long. It can be 3.1 meters tall, so floor to height 3.1, and it can be 300 mils deep, which allows us through an open web solution in the other direction to span quite far across rooms. And it can do anything inside of those dimensional tolerances to the millimeter. I'm sure you've noticed all the people on the line. Quite amazing, that flat piece of board that's just carrying that panel around. It actually has a geolocator in the bottom left-hand corner, so on that angle it knows exactly when you've placed something in that where that corner is, and it uses that to calibrate for the next robot to place it in the right place. So I do have an engineering background, I get a bit nerdy about some of this stuff. Each one of those screw heads has eight screws on it. You can use all 8, you can use number 2, you can use number 7, it doesn't matter. The algorithm optimizes the screw locations and picks out which cartridges actually have screws in them to do that. So there, for example, you'll see just 1 or 2 being utilized as opposed to all 8. You don't need all 8. This is the final station on the robotic line, and so the video will come to an end shortly. But at this station, we mill out doors, we mill out windows, we mill out face plates, and any other cutting that needs to happen. Anything smaller than about 16 centimeter diameter gets milled to dust there with dust extraction. The doors and windows get cut with slight areas that stay fastened so that it doesn't fall onto the line. It goes into the MEP, mechanical electrical plumbing area, and we remove them there. So that's what our robotic line looks like. On our current trajectory, that line will be here and moving through that process with first saleable product coming off out of our Edinburgh plant on the 14th of April next year, just behind the state election, I think. Yeah. So the plant itself, 45,000 square meters of space, 14,000 under roof, 1,400 of office, just north of the city. I wanted to show this slide just to show you how the layout actually works. I might just go over here if that's okay. So the video you've just seen takes things through a saw environment, down the line, and then this butterfly table takes from a horizontal orientation to a vertical orientation as it travels up that green line. We know that it needs to get to the last horizontal line and back inside 10 minutes because that's how long it takes for a 12 meter by 2.7 meter panel to come down and be completed. And then these stations here, these are 3 stations that do all of your HVAC, mechanicals, your electrics are put in, your downlights are fitted, your windows are hung, your doors are in, external linings are on. All of that happens over there. Then to the right, we use our straddle carriers to take them out the door, put them on trucks and get them to site. The saw that you see at the bottom there is a turbo drive automated saw. I only reference it because when you talk scale of production, we were talking about that earlier, the volume of parts that go into a house, it often isn't immediately obvious, but for a traditional two-bedroom home, that saw has to do 4,000 cuts to make a single home, right? So why would a human have to do that if I can use a robot to do that? All right, so we're using the best hardware and software in the world to bring this together. So KUKA, the German business behind the robots, 4 billion euros, not dollars, apologies, 15,000 people. Waypaver, who are, Matt's visited that factory, actually Joe Noon's been there as well. They've got their own factory that you can actually see in the next slide, so that image on the top right. That's their 48,000 square metre factory. Those are all the modules that they're storing outside, ready to go to site. They do 2,200 homes a year out of that plant. That's in Boise, Idaho, of all places. All right, I am going really quickly, I apologise. But I think this is really some of the meat and potatoes for the people in the room. So the language on the left there comes out of the World Economic Forum and out of McKinsey. That's their research. So it's telling us that 13% of global GDP is the construction sector. We know from productivity recently here that construction is the worst performing for productivity over the last 2 decades. And inside construction, residential construction is the worst again at negative 29% of productivity over the last 2 years. Some of that absolutely around compliance, some of that just around how we do things. So McKinsey's quote is, for those that get this right, the prize is potentially vast. I think they're being capitalists in that statement, but you can take that into social outcomes as well, of course. Using our methods, a standard two-bedroom home, 114 man-hours, traditional build, 562.5 man-hours. Obviously, that translates into savings. Obviously, that translates into time. Some of our ESG. So, as you saw with the robots put a screw where the software tells them to put a screw. They never miss that location. We've engineered solutions for lateral loads without portal frames because of dynamic environments around where screws are actually located and how those loads are transferred. That's how accurate they are. Using timber gets us 82% less embodied carbon. I think for people in the room who have clients in the lower part of our socioeconomic outcome and people who are looking to save, because of the precision engineering, the homes are airtight. Our R values are off the charts, 30% less energy in use. So it costs less to heat and cool your home. And then all the other good stuff. So some of the things that aren't immediately obvious when you talk modular are when you use your algorithms to optimize how you produce less waste. You then have less waste on site. There are savings to the builder for waste going to tip, obviously. But we know that in a traditional two-bedroom home, we produce 90% less waste annually. Same for same, yeah? Okay, we get a 7-star rating right now. We don't get 8 because I can't control the orientation of the home. But if it was in the right direction, then we get 8. So for the people in the room, I think it's important to understand we are client-led design. We're not that Henry Ford thing I talked about earlier. You give us your drawings. We optimize them through a design for manufacturer analysis. That output is then shared with you. You can option those savings or not. It's up to you. If you're absolutely wedded to the length of a wall, we can make it the length you want. We then convert all of that through our software into machine code, send that down to the robot servers, and the robots do the rest. All of that automation happens in a 2D approach. We think that that's a good approach because it gives us flexibility both in terms of design but also freight. The moment you build a box and freight it, you're freighting air. Great solution for the site works, bad solution for transport cost. And the fact is our weather's pretty good, so we don't have that same... It's a bit of a furphy if builders tell you that weather's a big impact on their cost. It's about 2.3%. So we can do spandrel walls, 6 robot stations. I'm going fast. I'm conscious of where my time slot is, and we're all wanting to get to the Strathmore. Sorry. All right, and so you can engage with us either at a minimum level, we'll make the frames for you, but we can do all of that work around lightweight external cladding, internal linings, walls, floors and ceilings, electrical wiring, plumbing, insulation, windows, doors, downlights, and of course we put a wall wrap membrane on, which is a part of how we get to those wonderful ESG outcomes. The wall wrap membrane happens on the line as well, so there's no humans doing most of that. All right, and we engage on a project-by-project cost. We know where that sits, and it depends on what the client needs. So if the client wants a particular type of finish on the outside, that might cost more, but if it's a standard fibre cement board or not, we can drive those savings through our clients are governments, community housing providers, developers, and builders. And on a single shift. So a single shift for us is 7.5 hours a day, 5 days a week, 48 weeks a year. We can make 972 two-bedroom homes a year. If you want them to be 3-bedroom, our capacity comes down. If you want them to be 1-bedroom, the capacity goes up. If we go from 120 square metres on a 2-bedder down to 80 square metres on a 2-bedder, we produce almost 1,400 homes a year on a single shift. We can flip to a second shift and we can double our output. I think it's really important to share Commonwealth Bank. For those in the room who know about Commonwealth Bank and their commitment to the space, I was just sharing with James, 30 years of business have made me a complete cynic, and for good reason, around banks and how they operate. And when they tell me about social license, it's in one ear and out the other. But Commonwealth Bank have absolutely shaken my foundational belief in that comment. They've been amazing. So they've given us significant support. They've come in for 8 figures of debt, which admittedly makes me nervous, but I've thanked them for the opportunity to work for them for the rest of my life. I have a wonderful board around me that I've brought together to support me. I have a lot of blind spots. I tend to get excited. They are really grounding and help me make good decisions with a wealth of experience in the right spaces for us. We're already working with local Adelaidean businesses for to make sure that our product comes off, meets all the codes. National Code of Compliance, obviously. Standard groundworks, raft slab, up we go. And if you are thinking about density, if you build a podium slab, our product can go 6 levels off a podium slab without issue. And I've thrown a huge amount of interest and I hope language at you that you are thinking about and resonating with you. That's what we're up to. I look forward to folks who want to come and see it in a few months' time. Please feel free. Thank you.